and welcome to CDEP News. My name is Gilberto Lozada, and today, in this TV special, we're commemorating chemistry in different areas of science. First of all, medicine, with our expert Angela Martinez, who is going to explain to us how synthetic insulin is made.
Hi. Well, insulin is a protein hormone composed of two chains of amino acids. Chain A with 21 amino acids and chain B with 30 amino acids, linked by a disulfide bond. To develop synthesized insulin, scientists synthetically create these two chains by joining a small piece of DNA in a specific manner. Then they are stitched into plasmids and introduced into E. coli bacterial strain. In there, they are switched on and produce an A or a B strain. When the cell has produced enough amounts of A and enough amounts of B, they are isolated and chemically combined to form a complete insulin molecule. This is just how scientists have developed new ways to solve problems like diabetes.
Thank you, Angela. Now, for our section in chemical warfare, Dr. Gilbert Baggins. Thank you, Gilberto. Virginia Tech is assisting the military in developing materials that trap and render harmless chemical warfare agents, such as sarin and VX nerve gas. John Morris, professor of chemistry with the Virginia Tech College of Science and the lead investigator on the project, said that the aim of their research team is to develop materials that can be incorporated into air filters, fabrics, and gas masks for protection of soldiers and civilians. Very low concentrations. For example, sarin can cause death within 1 to 10 minutes after direct inhalation of a lethal dose, due to suffocation from lung muscle failure, unless some antidotes are administered quickly. People who absorb a non-lethal dose but do not receive immediate medical attention may suffer permanent neurological damage. Sarin attacks the nervous system by interfering with the degradation of the neurotransmitter acetylcholine at neuromuscular junctions. Death will occur as a result of asphyxia due to the inability to control the muscles involved in breathing functions. The group at Virginia Tech is focusing on uncovering the molecular scale reaction pathways and determining the reaction rates where not toxic mimics of a chemical warfare gases, which are fully benign, come in contact with catalytically active materials that are dangerous. These are being developed by researchers at Emory University. Thank you, Hugo. Now, introducing chemistry in global warming, we have our correspondent, Itza Martinez. Itza, what can you tell us about how chemistry affects global warming?
As you may be well aware, the global warming is the heating of the Earth's surface, and it begins with the greenhouse effect. The amount of greenhouse gases has increased during the 20th century, and it has made the use of energy and the expansion of the global warming grow. One of the major components that contribute to the global warming is methane. CH4 is a natural gas found underground and it hosts infrared radiation damaging the Earth's surface. While methane is a more potent greenhouse gas than CO2, there is over 200 times more carbon dioxide in the atmosphere. Hence, the amount of warming methane contributes in 28% of the warming CO2. Chemistry is very important in our daily life because it helps solar sciences understand a useful concept for the human development. But maybe we're using all the discoveries wrong, and we're just damaging the only planet we have like we have another one to live in.
Yeah, I have heard that there have been several problems concerning global warming and the melting of polar ice caps. What do you think could be a possible solution here in Mexico?
Well, what I would recommend is to tell people of the consequences of the changes of the weather and why it's really important to know what is happening to our world right now. Second, I will locate which are the main producers of harming gases, and third, I will create a solution to air contamination so that they don't harm that much. For example, the use of eco-friendly cars.
Thank you, Itza. Now, our last section with the expert Alejandra Guerra, who is going to tell us about chemistry in food. Go ahead, Alejandra.
Good afternoon. Preservatives in food are a common topic nowadays because consumers associate them with dangerous and harmful chemicals. But what they don't know is that we've been using them since several years ago to keep our food from going bad because of chemical, physical, or biological factors. Some examples of natural food preservatives are salt, sugar, alcohol, and vinegar. Another methods used for keeping a fruit from going bad are freezing, boiling, smoking, and salting. Some examples of chemical food preservatives are benzoates, nitrites, sulfites, and sorbates.
Well, it seems to me that we can conclude that chemistry is everywhere. In fact, chemistry is the base of most sciences, the ones we mentioned earlier and even more. It helps other sciences develop new technologies and discoveries to make our life easier. Understanding this will only make you more aware of how close we are to science. Thank you for your attention, and we'll see you next week.